Okay, welcome everyone to this seminar called Smart Hull Maintenance, Data-Driven Strategies for Performance and Compliance, organized by the BS Group, so thank you so much to them. We have 3 presenters here today, and in addition to myself. My name is Irene Øvstebø Tvedten. I'm a senior advisor at the Bellona Foundation, and I will moderate this discussion here today. We also have Volker Bertram from DNV, senior project manager and lead trainer for the Maritime Academy. We have Rune Freyer, serial entrepreneur at Shipshave, and we have Ditte Gundermann, manager health performance and analytics at Hempel. So welcome to all of you, and welcome to all our listeners today. This webinar will last for 1.5 hours. We will start out with 4 presentations, and then we'll have a discussion at the end. But we also will do some small questions as we go along, a poll that we will present the results from at the end. And we also have a Q&A, so you can pose your questions during the seminar, and we will go through as many of them as we can at the end of this webinar. So I thought I would start out with 2 of the poll questions, so we just get started, all of us. So if I could ask the organizers to present the first poll question. Here you are. If you look at I think you are able to see the polls on the right on your screen. The first poll question is, how often does your company carry out hull inspections? So if that accounts for your company, we would love to have your answer to that. Great, and I can see that the majority of the people here today are ship owners, ship operators, and coating technology or service providers. But the numbers are increasing, so we'll see who represents the biggest group here today. But there seems to be a broad range of stakeholders attending today. That's good to see. Okay, so I would love to welcome Volker Bertram to take the stage and do the first presentation here today.
Yeah, hello from my side. I guess I have to upload again my presentation. There we go. As my theme here is new developments, high-tech developments for hull management. And that's a fun thing. I'll give a bit of an overview of what I've been observing at my conferences over the past years. Hull management is generally en vogue. Well, we have quite an illustrious and large crowd today in this webinar, and that reflects the general interest. And hull management is en vogue because it offers significant energy saving potentials, and the industry is increasingly aware of that. And it is also aware that in order to unlock this potential, they have to change the business as usual and adopt assorted innovations. And I'll give some highlights of those. One could say it all starts with the coating. And the key manufacturers, we have Ditte from Hempel here, for instance. They are very busy, or have been very busy, investing money into getting new generations of coatings with a lower biocidal footprint. And one of the developments there is to have coatings that are not only smooth, but also easy to clean. And we'll get that, I think, again, I think with Ditte and with Rune, that you can't look just as cleaning and you can't look just as coating. The two are linked, and the right strategy should be matched, coating and cleaning approach. Before I talk more about the cleaning approach, a little interesting sideline that we have also non-coating technology to help us to protect against fouling, and especially for niche areas, ultrasonic protection has enjoyed increasing success. I think that's very interesting for the niche areas, because we'll see niche areas are not really good friends of robotic cleaning. At the conferences, there has been a recurrent mantra that has come from coating companies, that has come from cleaning companies, and that has come from academia. And that mantra says clean frequently and clean softly. And the Norwegians call that proactive cleaning. The Americans call it grooming. It's the same thing. It's relatively frequent as, let's say, every 2 weeks, or even more frequent than that. Cleaning of the hulls with very gentle cleaning approaches, so it addresses the microfilm, the bioslime, before larger fouling can develop. And that kind of frequent cleaning keeps the biofilm low and keeps the penalty low. And here's a nice image that Jotun supplied, and say in that case, looking at business as usual over 5 years versus more frequent cleaning, you see a significant saving impact. Well, in order to get the saving, you have to do the frequent cleaning. And in order to do the frequent cleaning, you need to, you need to change your approach. You can't do that with human divers. And so, hen, chicken, egg problem, we've seen the need for frequent cleaning, and we've seen in parallel the development of robotic technology. Robotic technology for hull inspection, but also robotic technology for the actual cleaning. And that arguably has been a faster, or maybe more noticeable, innovative approach than on the painting side. On the painting side, the handicap of the paint companies is it's very difficult to make a sexy photo of a pot of paint. And at first glance, we, the humans, just see the paint and not what's inside and the performance over 5 years. While a robot is funky, and you can make nice movies with that. So let's have a look at what's happening on the side of robots. Robotic technology moves forward, I would say, on various fronts, gaining new capabilities, learning new tricks. And one of the very useful tricks is that the robots have machine vision, or increasingly the technology for machine vision has been developed. Machine vision allows you to identify fouling. It can say, this is a barnacle, or this is seaweed, or this is that kind of mussel. But it also allows you quantification of fouling. And the quantification with machine learning is that, at least if you stay within the same software, you show the same image and it will estimate the same percentage of fouling. While humans by nature very Ditte may estimate something else, Rune may something else, and even I myself may estimate something differently on different days of the week. So we have a more repeatable, more reliable quantification using robotic machine vision. We also can use other sensors to quantify the fouling. Um, Rune will, I guess, move into that, measuring roughness on the ship with his robot, unmanned cleaning device. And you can use other technologies to do that. And by now, we have a resolution that goes down to micrometers. So you can identify the individual barnacle. And they become team players. If you want to clean a ship hull, 400-meter long ship, the robot shouldn't be too large, so it can handle curvature on the hull. Then it's possibly a good idea to have more than one robot doing the job. And if you have teams or swarms of robots talking to each other, collectively, for instance, mapping and identifying the cleaning state of a hull, then you could do the cleaning of a ship in shorter time. And the next and perhaps game changer in the whole story of hull management is in-transit cleaning. There, we may have to take a step back and say in-port cleaning by divers and or robots has become increasingly difficult over the last years or decade. Ports increasingly take the approach that they want to have clean ships coming into the port, but not ships cleaned in their port, not in my backyard. And so it's increasingly difficult to get permits to clean in the ports around the world. And part of that is that with cleaning, there's the concern that both biofouling and paint particles, microplastics and biocides, may be released into the port sediment, and that may contaminate the port sediment and even contribute to spread of invasive species. Now we circumvent this thorny issue if we clean at high seas in international waters. And that's the in-transit cleaning. The clear leader of the pack, pioneer in that field, is Rune and Shipshave, his company. But we do have new startups, new young lions trying their ideas there at Twitch. And we should mention at least Nakai in Israel with crawling robots and Larabicus in Germany. Finally, when should we clean? That is increasingly driven by performance monitoring, advanced performance monitoring. My own history with performance monitoring goes back 10 years, and the group back then had the usual factions and debate, the fundamentals against the realistic guys, etc. And in our case, it was naval architects against machine learning AI generation. Should such a performance monitoring approach be based on tried and proven and physical insight, naval architectural knowledge, or is it data analytics and everything will work out with the magic of AI? Well, the truth lies, as often, in the compromise and say it's not either or, it's why not both, combine the best of both approaches. And increasingly, we see advanced performance monitoring coming in with mixing naval architectural insight with AI. And sometimes we can call that then physics informed machine learning or physics informed neural nets. With that, I want to leave some time for question and discussions, and also the other experts out there. Just a quick that I tapped shamelessly into the knowledge and good work of many other colleagues, not my own. And those were presented at Halpic and Portpic, the conferences there. Google them, or if you want to know more or be involved, then send me an email. Thank you.
Thank you, Volker. I'm sure you have been listening, have quite a lot of question after this interesting presentation. So please just write your questions in the Q&A and we'll go through them at the end, as long as we have time at least. As I said, we have some poll questions from the BS group. So I thought we would do 2 more questions from the poll, and we'll go through the poll results before the discussion at the end of the presentations. Can you see the polls now? That's good. Okay, so then I am honored to present the next presenter, Ditte Gundermann from Hempel. The floor is yours, Ditte.
Thank you. So let's see if I can share screen. I think I did, and window, and then that one. Yes, I think it works. Good. Yeah, so I will talk about coatings and how combination of coating and monitoring, and also, if needed, cleaning can be or is a very good strategy for fuel optimization. First, I'll just present myself because I'm not as famous as Volker, so I think I may, so not all of you may know me. So yeah, my name is Ditte. It's a Danish name, difficult for many nationalities to pronounce. I have a background in physics, but started working with performance monitoring a little more than 10 years ago. And then 8.5 years ago, I joined Hempel, working with in the performance team there. And then I wanted to also just add here that I'm a what I would call a Halpic veteran. I've been to almost all Halpic conferences, and I can really recommend them as a place of inspiration and knowledge about hull performance. Yes. Yeah, so just to repeat, I mean, the reason why we are here is because we have a shared challenge or problem with biofouling, which when on ships hulls increases fuel consumption and emissions, and also increase the risk of spreading invasive species. So Hempel has been making anti-fouling coatings for more than 100 years, and as such we have a long history and a lot of experience in fighting biofouling via coatings. And I've just shown here a timeline with some say highlights, and I'll not go through all of them. We can start. So it doesn't show the entire history, but the last 50 years or so, starting with the first generation silicone in 1972, and then up to today. And I will again just mark a few things. So first one is the launch of the Hempel 7, which was a revolutionary new technology of a silicone with biocide, which really improved performance significantly. Then also 2012, we started in Hempel engaging in performance monitoring, first with externals like DNV, force technology, and also propulsion dynamics, which has since been bought by Zero North. And then say we've also launched new silicone products, but also engaged more and more with digital and analytical solutions, which has culminated in the last thing I'll highlight here, our online shape portal, which is available for our customers and colleagues, where they can see performance of the fleets and environmental fouling risk, etc. I'll come back to that later. Yes, so I'll just try. Volker talked about the future of coatings and solutions in general. I'll just give a very brief overview of existing main technologies. First one is this, what do we call, traditional anti-fouling, so the self-polishing coatings, which has been dominating in the last many decades, and around 80% or more than 80% of the world fleet have them applied today. So they rely on a combination of biocide and this polishing effect, which means that the coating is all the time releasing a little bit of the outer layer of the coating in order to always have active biocide at the surface. So in recent years, there's been more increased focus on or the environmental conditions and marine environment, and this release of both biocide and microparticles have caused some concerns and some questions about this, whether this will be a future sustainable solution. Yeah, then we have the silicones, which is right now the fastest growing coating type. It has different advantages. First of all, it doesn't polish. It has this so-called out-of-dock effect, which means that it's even from application. It actually has such surface properties that you can save fuel from day one compared to the SPC type coatings. Then on top, they have very good anti-fouling properties, especially a product like Hempel with this little bit amount of biocide in also. So some people are concerned about the mechanical properties of the silicones because they are softer and they can more easily be damaged. I'll address this in the next slide. Finally, as Volker also mentioned, we have seen this new type of coatings, these so-called hard coatings, which are designed for frequent cleaning. They have very hard mechanical properties and usually don't have any anti-fouling properties itself, but rely on the anti-fouling mechanisms to come from the robot or the cleaning. They are also claimed to have some out-of-dock effects, so have this beneficial effect from the first application compared to traditional self-polishing coatings. Yes, so one concern could be that if you are not able to clean for some reason, your robot is broken, or for some other practical reasons, then what then, right? Well, then you are left with no protection. Yes, so I will now explain why our recommendation for optimized fuel consumption is a combination of silicone and performance monitoring, and then the right amount of cleaning. Yes, so to address the question about how well suited silicones are for cleaning, I'll show some results of tests that were carried out by an independent third party, where they tested silicone on panels in static immersions, comparing non-cleaned and cleaned coatings. First, we have a test panel or a reference panel, which is an uncoated panel that you put down there for reference, just to show what is the potential fouling, you can say, or the fouling pressure, as we call it. So this is after 60 days. And we have also, after 60 days, 2 panels with silicone on. One was just applied, Hempel, and another one that had initially been cleaned more than 200 times before it was then immersed, to see how was this the surface affected by the cleaning. And as you can see, there is a difference between the two. The right panel, which has been cleaned, has slightly more slime on it. So it does affect, but compared, of course, to the unprotected surface, you can see that it has still a very high performance and are able to prevent fouling even after many cleanings. I have another one here, which is from our internal test facilities, which shows also a similar test of a cleaned and non-cleaned panel with HempelGuard after longer idle or longer immersion of 441 days. Yes, so just to summarize, unless you are cleaning very frequently, then it's still a really good idea to have some antifouling properties in the coating. And although HempelGuard is somehow to some degree affected by the cleaning, it still has very good antifouling properties even after cleaning. Yes, so just to also show, say a little bit about how such a scenario could work with a combination of HempelGuard and cleanings and monitoring, I will show again this figure that Volker also showed with this saving potential from going from this, say no cleaning to proactive cleaning. But I will argue that there's even more to save when looking at this yellow curve. First of all, if you apply silicone, you will get this out of dock effect. So you will actually from day one reduce your power or fuel consumption. In addition, you will have very nice performance in the first at least 2 years. So you will not see this as rapid increase in power or fuel consumption. And then even once you start cleaning, you should also see less fouling accumulation between the cleanings, reducing these peaks that is illustrated by the yellow. And just an estimate that you can save up to 10% on average by going to this, applying this strategy. Okay, so then if you want to really optimize performance, what should you do then? Our recommendation for a scenario with HempelGuard, performance monitoring, and potential cleaning is that you, for the first 2 and 2.5 years, basically do nothing else than monitor, making sure that you don't see any performance deterioration. You do propeller polishings at least every year, but preferably twice per year. And in that connection, you can also do an inspection just to make sure that what you see there aligns with the performance monitoring. In by far the most cases, you will have nice performance in the first 2 to 2.5 years. Then in year 3 to 4, you keep monitoring, and it's really important that you have good monitoring, you have good data and also good methods for analyzing the performance. And once you see a performance deterioration, we recommend that you do an inspection prior to the first cleaning. That is just to make sure that you actually have fouling, so you don't initiate a cleaning if there's no need for it. It can also be that you only have fouling in the waterline or in certain areas, so you may not need a full hull cleaning, but only target those areas. Again, you keep also polish the propeller as in the first 2 years. Yes, so finally, we have the last 1 to 1.5 years where you again continue monitoring, propeller polishing, and in most cases, if you want to have optimum performance throughout the lifetime of the coating, cleanings will be a solution, especially in the last year, and especially once you have started the first cleaning earlier. So all of this, of course, the timing for starting the cleaning will depend on the vessel operational profile, etc. And in principle, this concept applies for all coatings, but then again, the length of this individual time periods will vary depending on the performance of the coating and the ship type and operational profile. Okay, finally, I just want to mention some of the new things we have, or the other services we are offering, because Hempel wants to be not just a coating supplier, but we want to be a partner in hull performance. And for that purpose, we have these different services on the portal that I mentioned. Those are performance monitoring, where you can see if you are enrolled in such a service, you can see the performance of your vessels. You can also see fouling pressure of all your vessels, coated with Hempel or not. And you can set up alerts to get notifications if your vessels are trading in, you can say, what we call high fouling risk areas. And finally, we also have all the visual data that we have, and we have this AI visual analysis. You can upload photos, and as Volker mentioned, we have image recognition that quantifies the fouling based on those images. Yes, that was, so just to summarize, hull coatings matter even in a scenario of frequent cleanings. Proper data is essential. That's really important. It doesn't have to be high frequency, but this higher frequency, the better quality you have, the sooner you can make a decision about potential maintenance. Yeah, and then finally, also, as Volker said, the maintenance strategy should match the coating and the vessel type and the operational profile. So the lower performance coating and the more mechanical damages you have, and the more idle time and longer idle, the sooner you will need to start maybe a cleaning schedule. Yes, and I'll say only clean if necessary, and get in contact with Hempel if you want to discuss hull maintenance strategies or get advice. Thank you.
Thank you, Ditte. I haven't heard about those tests before, so it was very interesting to hear about those results. If you have questions for Ditte, please just tag her in your quick Q&A, and we can hopefully go through them at the end. And as I mentioned, BS Group has prepared some poll questions. Some of them are mainly targeted at ship operators and owners. So if don't feel targeted by the question, you can ignore it. But 2 questions are now going to be published. And while you reply to those, I would like to introduce Rune Freyer from Shipshave, an in-transit in-water cleaning provider. The floor is yours, Rune.
Hi, thank you. I will discuss. Just hold on a second. I will discuss our visions about. Page up. I will discuss our tools and our visions and our strategies for how to handle data management and create big info. I don't like big data because it basically you need to make information out of the data before it's usable for anything. If I just find out how to run this video. No, I didn't. Yes, hold on a second. Yes. Okay, this is our hull cleaning robot, the itch in-transit cleaning of hulls. It's working by using the flow around the hull, and it's controlled by internal electronics to work up and down along the hull. And it has brushes under, so it's cleaning the fouling. However, this allows us to monitor the hull while the ship is sailing, which is quite it's unique really to be able to do that, and that can give us a lot more information about the hull. Okay, here we finally see the video of the tool while working. So showing efficient removal. This is a bit late life or in the docking cycle. Please switch to next. Yes, so what is the greatest advance in medicine since the 1800s? What is the most important advance in medicine since the 1800s? Is it penicillin? Is it hand washing? Or is it actually the statistics? Next screen. The statistics to analyze all of this, because the more data you have in medicine, you're not allowed to do any innovation without having thorough statistics on it. In shipping, that's we have less data and we have less processes on that, but I want to add processes to that. Next screen. So with each, it's this robot. It's used by the crew. It's used on any ship larger than 128 meters commercially today. Any draft deeper than 6 meters and up till 17 knots. Basically, you have a winch sitting on a foredeck. And reeling out this unit, this robot along the hull, and it's working up and down. And on board of this unit, this robot, there's a number of sensors, including cameras and an optical sensor. Next screen. We have 140 systems in use with 40 customers in all major ship types, and we have proven 2 to 16% fuel savings, different for different types of vessels and different ages of vessels. And we spend 60% of our expenditure is on R&D. A lot of that is on the software. Next screen. This is a case analyzed by DNV on 2 ships from Hapag-Lloyd, large container vessels, where you see over time the red is before cleaning, and the green is after cleaning, and the verticals are cleaning events. So you basically see that we lower it and keep it low. But we don't want to see numbers like that. We don't want to see that we're saving 16%, because we want this cleaning operations to be performed before it becomes this much degradation of hull performance. Next screen. So this is our philosophy, on which Volker also mentioned. Basically, if you clean in harbor, you capture the effluents, and some of it is, or most of it is caught, but not all. Our alternative is to do this far offshore, and therefore that the organisms will not find the surface to settle on and prosper. Next screen. So a lot of the analysis is done in harbor with ops ROVs, and this is our own tool, but it's the same for every tool. It's basically that if you don't have clean water, you don't get good information, and you can get classification, you can get AI to make classification and so on, but it comes short of actual measurement of the painting and anti-fouling, and it comes short of measurement of the fouling in itself. So with measurement of the roughness, why is roughness important? First of all, yes, because it's increasing the drag of the vessel. So and then you can say before the ship is launched after dry dock, you can measure the coating and the condition, but you generally don't measure it underway. So what is the paint degradation over time? What sort of berthing damage do you have on the paint? That was mentioned, softer silicons and but how important is that actually? And you can compare the silicons and the self-polishing. You can there's a lot of avenues for how to improve your performance, and which coating works nicely in the boot top area and the bow and so on. Can you get numbers on that? And only if you get numbers on problems, you can really solve them. You should be able to get fouling trends. A lot of discussion of when the fouling starts and so on, but you need hard evidence. You don't need pictures. You need measurements. And also we see air lubrication. How can we help that with our data platforms? Next screen. This is an example of an actual cleaning done where we see a matrix of one hull side with the bow to the right and the aft to the left, and the draft position on the vertical axis. So, and there you can see that we get reduced the roughness of each of these segments of the hull. Next screen. So here we see this solely on a depth basis, not a distance from bow basis. And here you can see the shallow parts of the hull has high roughness, and the deeper has lower roughness. And you can see the difference and the improvements of the after from before the cleaning and after the cleaning. Next screen. And this is showing this in real life, where you see the shallow portions on the left and the deep portions of the hull on the right. Next screen. So what we want to create is not only one picture of a hull of one time point of time. We want, because if you look at the traditional doing roughness measurements before the hull goes into the water and after docking. Then you may have 100 measurements before and 100 after, so you have 200 measurements in total. By the way, this is log scale of measurements, and it's months on the x-axis. So it's a full docking cycle. With each performance, you get typically 100,000 or maybe 200,000 measurements on the cleaning. So for every time, say you clean the hull every second month, so every time you're getting a full data capture, and you get a full resolution of where this happens on the hull, and then. But one ship alone is not information, that's just data again. But if you aggregate this over a fleet, then if you have 100 ships, then you have 5, 6, 7 times the data. 5, 6, 7 orders of magnitude greater amount of data on roughness than a traditional approach. Next screen. So then you can do a lot. You can, for example, compare Ditte's paint and Petter's paint, or you can discuss single vessels in your fleet, which are the worst performance, which needs attention. You can find out is really berthing areas a bigger problem on SPC or silicons. There's a lot when you have this much data. There's a lot you can do with it, and you don't have full overview before you start with such a system of all the questions you can get answered. Next screen. And maybe, well, I stole this picture on the web about air lubrication. Yes, this is how all the models show that air lubrication works, but maybe in some conditions, maybe with the waves and roll, and it behaves different. So next screen. Maybe it looks like this, and then it looks like this, and so then we can identify where would this happen, and how can we, and then we can calibrate CFD models and so on to see how it is in real life, and how you can next design improve it. Next screen. So our development work, please note that we're a commercial company, and we have equipment, and we sell equipment, and we work with customers, and we have repeat customers. But we have two main efforts, and that is functionality, which goes on to make this scalable, make it efficient for the performance engineer in the office and the users offshore, being efficient in cleaning and being efficient with the end users' time. And then we have the information part of it, which goes on both the paint in itself, measuring the roughness of the paint and looking at the fouling, or measuring the fouling, and then how to how to gain knowledge from this, both with AI and more traditional analysis. Next screen. And then I'm thinking a little bit on implementation, because we want to be able to help. A lot of the innovation is coming from small companies, and small companies often have a different urgency than larger companies. So I'll talk a little bit about implementation of how this is done. Next screen. So we know that with a diver cleaning, there's a significant risk of damaging the paint. There's not, if you're looking at Swain, and if you're looking at all the tests we have done and all the inspections we have done, we don't see the paint damage. But after we're done cleaning, our own cleaning, we easily remove the fouling next time. But after we approach a hull that had been diver cleaned, it's far harder to remove it. So there is a significant damage there, and I don't think that the current risk is really appreciated and calculated enough. Secondly, next screen. I'd also like to when I was relatively new in the industry here, I looked at, there was a MSC bought 30 systems of Silverstream, and I thought that was really cool, because this is scaling. The fleets are pretty standardized, and this shows how the industry can go scaling. In fracking in the US, people are scaling. People are doing smaller or larger changes, and they're getting the efficiency. That's why we have cheap fuel today, because US is now the largest producer of oil and gas in the world, and that's because of innovation and fast-moving technology application. Same thing with solar, large scale, and the shipping industry will also by going faster. We find that every new customer we have the same qualification projects repeated, and it's very time consuming. So if I can encourage to improve the deployment of new technology, then going for increased speed is great. Thank you.
Thank you, Rune. I'm sure there are many questions after your presentation, because I've looked at the Q&A and there are many questions already from the other presentation. So looking forward to going through some of them. It's now my turn to make the final presentation. So I will just start out and see if I can share my presentation. Here we are. So we've heard about the coating manufacturers. We heard about the various robotic solutions that are available. But the key player in all of this are the ports and regulators, who need to allow the actual in-water cleaning. And partly for that reason, Bellona initiated an ISO standard on in-water cleaning a few years ago, and I will talk about that. I will also mention another ISO standard that the same working group has been involved in. Can I just first ask the other presenters to mute their microphones, please? Thank you. So my name is Irene Tvedten. I'm a senior advisor in a Norwegian environmental NGO that was established in the 80s to protest polluters and polluting companies. We have moved on to point to green solutions and green technologies that we believe in. And we have started the Clean Hull initiative because we believe in proactive in-water cleaning, ideally on hard coatings in the future. And we have also initiated an ISO standard based on the Clean Hull initiative. And the reason we started that ISO standard is that we saw that there were some bottlenecks in the way of proactive in-water cleaning. This is a table from the Globe Fouling report in 2022, where ship owners replied to what their greatest challenges were in terms of complying with biofouling policies. And one of the greatest challenges was the lack of consistency with ports and countries. And this ISO standard hopefully will do something about that and harmonize this the regulation between ports and countries while we are waiting for a global regulation on in-water cleaning from the IMO. So what is an ISO standard? This is ISO's own explanation. It's internationally agreed by experts, and one should think of them as a formula that describes the best way of doing something. And this is how it all started with the Clean Hull initiative and my colleague Rune, who was the project leader of that in 2021. And they wrote a draft and sent it to the ISO applying for an ISO standard on in-water cleaning. And that application was approved. And then the ISO established a working group, which I then became the project leader of. This is the ISO working group. It was, and still is, comprised of 70 experts from all over the world, representing 12 countries and BIMCO. And I think almost the whole range of stakeholders are represented in that group. This is some of them. I would say in general, maybe there were 20, 30 people present in each meeting. And this has been a hard-working group because they have not only developed one, but two standards in parallel, both ISO 20679 and ISO 6319. So I'm the convener of the group, but I'm the project leader of 6319. Therefore, I will talk mainly about 6319, but I thought I would briefly mention what 20679 is all about. This one. As you can see, the project leader of that is Professor Mario Tamburi, who many of you may know. That standard is already published. So it's called Testing of Ship Biofouling in-Water Cleaning System. This is an ISO standard on testing in-water cleaning systems. And the scope is that it provides procedures for the independent performance testing of all forms of in-water cleaning systems. And it includes testing protocols and describes how to report on the efficacy and safety of in-water cleaning systems. So if you are interested in that, it's downloadable on ISO's webpage. It costs a bit of money, but hopefully worth it. And then there's ISO 6319, which I'm the project leader of. This is the title of that one. It's conducting and documenting in-water cleaning of ships biofouling. And as you can see, it's within the category of marine environmental protection. So this is all about conducting in-water cleaning in an environmentally sound way that protects the environment. What this standard aims to do is to harmonize these stakeholders' requirements, as I mentioned in that table, and help ports and jurisdictions to evaluate applications for in-water cleaning that they receive, and also help them ensure that the in-water cleanings that they actually allow are conducted in an environmentally sound way. And they also help ship owners. The timeline for this standard is that it's supposed to be finalized in January next year, and it's already in the publication phase. So I hope that it's published sometime this fall, maybe September, maybe October, who knows. It's going to be very exciting when it's published and when people will use this in practice. So I've cut the scope down to 3 parts. The first part says that this document is about planning and conducting in-water cleaning safely, efficiently, and in an environmentally sound manner. And it's also about reporting on the effectiveness of cleaning. And it's both on hull and niche areas, all levels of biofouling, with and without capture. Because what we realized is that when you prepare for an in-water cleaning, the various kinds of cleaning doesn't really matter. The preparation and documentation requirements are very similar either way. And as I said, the document has been established to inform ports and regulators, but it's also very useful for a range of other stakeholders. And as many of you probably know, the IMO published its biofouling guidelines in 2023, and this year they also published guidance on matters relating to in-water cleaning. The ISO standard is fully aligned with the biofouling guidelines. In terms of the guidance, it slightly resembles the guidance. I would say the guidance is a bit more, goes a bit more into depth in certain topics, while the ISO standard is more of a checklist that you can go through, slightly more practical potentially. And the IMO guidance also sets some requirements, while an ISO standard by default never sets the sort of legal requirements for example, impact on water quality or capture rates. That's up to legislators. So I just thought I would give some examples from the text itself. This is chapter 5. It's actually the first chapter, even though it's called 5. And it's about, for example, compatibility, which we're quite proud of because as far as I know, we're the first to define compatibility in this standard. And it's also about documenting the planned in-water cleaning process to the regulator in terms of multiple event approval, meaning a license for a long-term allowance. Chapter 6 is about hull condition assessment. So that's both an assessment of the coating condition and the biofouling condition, and combined with the review of ship operations, looking at inspection reports and looking at cleaning reports. Chapter 7 looks into the documentation for single event approval. So when you plan on cleaning in a port, you apply for that single event cleaning quite close to the actual event, and that demands a different list of documentation. And chapter 8 is the only chapter on the actual operation. It's quite a short chapter because, as we realized, it's more about the preparation. And one of the things that are discussed here is the coordination in advance and identification of areas to be avoided during operation. And the last chapter of the ISO standard is about the cleaning report and its content, naturally. So what does ISO 63 not do? It does not talk about establishing in-water cleaning regimes. And by that, I mean, it doesn't talk about proactive and reactive regimes. It doesn't talk about the frequency of cleaning. It talks about the isolated cleaning event itself. And as I mentioned, it does not set criteria for capture rates or water quality test results in terms of what the results should actually say. It does, however, say that testing is very important and that you need to provide test results to the port when applying. And we also refer to other standards on the topic of testing, inspection, and evaluation of fouling degree, which you can find at the AMPP. And hopefully this will prevent the spread of invasive aquatic species, because it will lower the threshold for ports and regulators to actually allow the cleaning of ships, so that more ships will operate clean rather than fouled. And at the same time, it will hopefully help them dismiss applications from service providers who are, for example, planning on cleaning macrofouling without capture, or don't have the proper system for cleaning the coating at hand. And hopefully it will also ensure human safety during water cleaning, because of the different documentation requirements that we have in this standard for about training and safety. So that was me presenting ISO 6319. Happy to answer any questions about that. Let me see if we have some more polls available. I will ask the administrators to publish them now, but I think maybe we've gone through all the poll questions. And if we have, they can just publish them and we can look at the results. And after that, we will have a more broader discussion with the four of us. And you as presenters, I encourage you to look through the different questions and see if you have any favorites, because there are so many there. So if you have a question that you would like to reply to, please let me know. Oh, I saw some results, but then they went away again. Maybe they'll emerge again. Here we are. Okay, so most of you are ship owners and operators. And there's also quite a lot of coating and technology service providers. Quite a few researchers, that's nice. Port and terminals, that's quite illustrative, isn't it? Quite a few, but thank you to the port or terminal or regulator who's present, and also a charterer, and 18% others. It's interesting. How often does your company carry out hull inspections? So the majority of you only when performance issues are noticed. And then secondly, regularly. So that's a big difference. Every few months or when performance issues are noticed. Or is it a big difference? Maybe you, Volker, have some opinions on that. How often are performance issues noticed? Oh, you're muted? You can't unmute yourself?
Oh, no. Old man trying desperately to find buttons, you know. You will get to that point. I would say it's quite a difference for the majority of the ship operators, because the ship operators that we have typically at the conferences that are good and interested in performance monitoring, they are a minority of the world. Now, for, let's say, high-level big players in container shipping, without mentioning any of those, but you know the usual suspects, they will notice performance issues quite rapidly, I would say 3-4 months, and then probably will, to some extent, drill down and see what to do about that.
It's good to see that at least people are cleaning quite frequently, from Bellona's perspective at least. Maybe not everyone would agree. Okay, so the next question is, what is the biggest challenge you face with hull maintenance? And the majority says that it's the operational downtime that it's recognizable from the conversations I've had with ship owners. What do you think, Rune? Is that exaggerated, or maybe it's not something you don't have that problem since you're in transit though?
Yeah, for us, it's a good answer. Where our ships are cleaned while sailing, so it's I can't answer for the ship owners what they think, but it's good to see that that we're hitting our audience with our tools.
That's good. What about you, Ditte? What do you think that 18% say that there is a lack of reliable monitoring tools? Does that surprise you or not?
No, it doesn't surprise
No.
me. I think it's maybe also lack of reliable data, I would maybe argue. So no, I think, yeah, there is a lot of poor quality data, and it's really challenging to do good performance monitoring, both with and without good data, I'll say. So it doesn't surprise me.
No. We also see that cost of cleaning and coating and access to cleaning system is also a threshold. Okay, so what is your company's approach to hull coatings? There's a big majority saying premium performance coatings with a fuel saving focus. So it's good that people at least have a fuel saving focus. That's good to see. I'm going to skip that quite briefly. How prepared do you feel for EU ETS and FuelEU Maritime compliance in relation to hull performance? And the majority says partially prepared. Who knows what the future brings, but there is some potential for being more prepared than apparently. Do you want to say something, Rune?
Yeah, I'm thinking a lot of the efforts that you can do is done in dry dock. So a lot of the efforts will have a five-year delivery time, basically, to get the improvement. So it's a limited amount of methods. Hull cleaning, it can be weather routing and so on, but there's a limited scope for people need to hurry.
Yeah. Well summarized. The next question is, which tools or methods are you currently using or considering for condition-based hull maintenance? And there's a big majority saying data analytics software platforms. Is this something that has been currently... Is the development going very swiftly on this, Volker? And is that why so many are considering this right now?
I would group A and B together, because if you don't have any sensors supplying the data, even the best of artificial intelligence bordering on voodoo will not, as one says, well, garbage in, garbage out. So probably the participants, joking apart, were just saying, well, I don't know, I'll click one of the two, and they are together. And again, I think over the last 10 years, and that's basically since ISO 19030 on performance monitoring came out, we've seen an evolution towards becoming better. The ship operators have become better and smarter, but I also think more realistic in what they have as expectations on a performance monitoring system. The solution providers and, for instance, Hempel with their shape systems would be among them. But, we have whatever 10, 20 companies that would do, in my opinion, professional, good performance monitoring, the best you can do, are doing their bit. And increasingly, I think we've seen that more ship operators or more ships have continuous monitoring systems on board. Data collection at every few seconds or so aggregating that, and that helps too. One thing is quality of data, but having a lot of data helps you to be, well, gives you a more free hand in filtering and getting then faster trends than noon reports.
Yeah, thank you. Okay, so one last question. In your view, how can biofouling increase fuel consumption if not managed properly? And the majority says over 20%. That's very interesting, and I think that's also correct. It can be that high. So it's good to see that ship owners and operators, who are the majority of the listeners today, are aware of that. That's encouraging to see. I wonder, Ditte, do you have a favorite question in the Q&A that you would like to answer to? I've seen you reply to them in writing, but maybe you could let the whole group, if you have one.
Yeah, I think the whole discussion about like fouling prediction is very interesting. That's something we are working on when we have time, and which I think will be. I know many different people and companies are working on that. I think that will make a big difference once you are able to predict the fouling accumulation on the ship, even without performance monitoring or even without sensor data. You could, in principle, predict only from operational data, AIS data, and environmental data. That would be really interesting. Also knowing, of course, the effectiveness of the coding at any given point in time.
Yeah. Thank you. What about you, Rune? Did you see a question in the Q&A that stood out?
Not particular.
Okay, then I have a question for you here. What value does data-driven information provide to ship operators?
I think it's very important both for how they select the paint and how they perform the maintenance operations. What do you know about the paint while you're going in dry dock? How do you prepare for it? I think there's a lot of value in more data. It's sort of professionalizing the selection to get more measurements and more information out of it. And it's hard to know exactly how much that is, because only creativity and experience with a lot of data will really show you how to use it.
Thank you, Rune. Volker, continuing on what you just talked about, what do you think the role of AI will be in the future in the context of hull performance?
Big one. If we go back to the definition of AI, then originally, back in the 1950s, people said, well, it's a basket of technologies, and one of the technologies is robotics. Now, if we single that one out, robotics definitely is going to move forward. We will have more companies, or we will have more ports with companies offering robotic cleaning, and Rune will work on that. More people will also have in-transit cleaning. But let's say what most people understand when you say artificial intelligence, and then they mean machine learning. And machine learning, as you can see, I'm an old man. I remember times when the same technology was called numerical statistics, but that was very bad in trying to chat any ladies up when you were saying you're working on numerical statistics. If you say, oh, I'm working on the latest in artificial intelligence, wow, it's a different game. So machine learning, I think what Ditte said is a glimpse of the next generation. We have seen machine learning used on developing baselines, speed power curves for ships. We're now moving into machine learning that says, oh, let's use statistics of the world for temperature and fouling pressure. Oh, let's move on and say we add a few more variables and say you use that kind of coating and let's say some few parameters to describe an operational profile. And that will, thanks to the data that we are collecting and the computing power, that's not an issue there, will move us forward to say more tailored precision decision making in that field. It will not overcome human stupidity. When we think about how charter party contracts are still done, then oh well, we will still see many ships where the owner says it's not me who pays the money and the hull management is not the best. But that's a story for another day.
Thank you, Volker. I wonder, Ditte, how do you see the future of performance monitoring if inspections become even more frequent?
Yeah, good question. I think frequent inspections is a really good add-on to performance monitoring. And I think it depends also on what it is you want to figure out. Do you want to know if you have a single barnacle, which makes you, I'm not sure barnacles are the big problem, but other types of species, which means that you will not be able to enter certain ports, for instance, then inspections might be a good tool. But if you are concerned about performance, then I think a combination of performance monitoring and inspections are still needed. And also in order, as Rune mentioned, if you want to do evaluate this coding versus another one, previous coding, or you want to evaluate different initiatives, energy saving devices, then you need performance monitoring and not only inspections. So I don't think it will end performance monitoring.
No, thank you. What about you, Rune? What do you have any examples on what can be done to accelerate progress within decarbonation? We've talked a bit about CII, ETS. What can be done to achieve all these climate goals?
I think every working together. That's a sort of it's a common theme, but there's many parties that needs to. Ship managers, what's the role of ship managers? We have some ship managers now that starts to look closely into and cooperate on, but things take time, and for ship managers to take more a role on this, and ship owners being progressive as. It's difficult to single out, but for all parties, but collaboration that we can work with Hempel, for example, can be very useful, and other paint manufacturers that we together find out how cleaning best can be applied together with their paints. It's important.
Yeah, working together. Are there other points that any of you would like to make that you haven't been able to make yet? Things that, or questions in the Q&A that you would really like to address before we wrap up here today? Yeah, Volker, please.
Just a short one. I understand the interest and the motivation and the desire of everybody who asks, if I take coating product X, Super Ditte 3000 from Hempel, how much can I save? And we should say, well, anybody who says X% should not be trusted. The correct answer, it depends. One important thing is the secret to success in optimization is to start badly. So take a really bad, of course, of a competitor company, coating on yours, and then and how do you even define how much better? Do you define a week after application in sea trial, or over 1 year, or actually at the end what the wallet is interested in over 5 years? And if you know a little bit about coatings, quite a few knowledgeable people from the ship owners, but of course also in the coating companies, you see that they don't follow the same characteristics. Some degrade more rapidly than others. So that should be kept in mind. Still, another thing is to say, well, what do you guarantee, and do you guarantee that with some sort of performance monitoring scheme? And I generally think it's a very good development also that we do have increasingly this salesman approach and said, I don't promise you the world, but I promise you something based on performance monitoring.
I think that's a nice way to wrap up this webinar, Volker. Thank you very much. This has been a great 1.5 hours. Thank you so much to our presenters. Thank you so much to BS Group for initiating this webinar. I think it will be available online afterwards if any of you would like to see that. And here you see some upcoming events organized by BS Group as well. I don't think in-water cleaning will become less relevant in the upcoming years because the IMO has decided to develop regulations on in-water cleaning. So we have some very interesting years ahead of us. Hopefully we'll have more seminars about this topic before that happens. So see you then, and have a wonderful day. Bye.
Bye.
Bye. Thank you.